Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over section 5.3 of our virtual geometry text and parallelograms. We're going to take a look at how to use properties of parallelograms to solve problems. For example, take a look at the problem we have here. We have parallelogram ABCD, and we're to find the value of x where its adjacent angle is 78 degrees. There are 6 practice problems at the end of this presentation that we'd like you to try out in order to demonstrate mastery of the contents of this presentation. To get access to our entire geometry course, Algebra 1, 2, Pre-Calc, and Calculus, just take a look at the links in the description below or visit our website at mathgotserved.com. Alrighty, there are 2 properties of parallelograms that we're going to be using, actually 3, to solve the problems in today's presentation. So to take a look at that, this is our website, mathgotserved.com/geometry. We're going to take a look at our vocab section. Okay, so let's take a look at what are we working on? Parallelograms, formula number 26. Okay, so these are the properties that we're working with today. All the quadrilaterals that we're working on are all parallelograms. Okay, that's the assumption. So we're going to be using 1, 2, and 3. Okay, properties 1, 2, and 3. The first property states that opposite sides of a parallelogram are parallel and congruent. Okay, so opposite sides of a parallelogram are congruent and parallel. And then number 2, opposite angles are congruent. And then number 3, adjacent angles, like what we looked at the opening of this tutorial, adjacent angles are supplementary. Remember, supplementary means angles that add up to 180 degrees. All right, so let's take a look at some examples. So as indicated earlier, all the quadrilaterals we're working with today are parallelograms. So for question number 1 and 2, we're going to be solving for x, okay? So question 1, let's say we have parallelogram AB, CD, and just to show you that they're parallelograms, this side is parallel to that side, and this side right here, side AB, is parallel to DC. All right, so let's assume that angle C is 78 degrees and angle D is x. So what is the value of x in this particular setup that we have here? All right, so what we know is that these 2 angles are adjacent angles. So what do we know about adjacent angles? For a parallelogram, we know that adjacent angles are supplementary. So let's write that down. In parallelograms, adjacent angles are supplementary. So if we apply that to this particular case, we know that the measure of angle C plus the measure of angle D will be equal to what? 180. That's what supplementary angles mean. Okay, so to find x, we're going to substitute what we know and what we need. We know measure of angle C is 78, and the measure of angle D is x, and that's equal to 180. All right, so by applying the property of parallelograms, we've been able to generate this algebraic equation in one step. So to solve this, we just simply subtract 78 from both sides of the equation, and that will give us our final answer. X is equal to, so we have 10 minus 8, 2, and then 17 minus 7 is 10. All right, so x is basically 102 degrees. Ladies and gentlemen, that is the answer to question number 1. Okay, let's take a look at question number 2. We're going to be working with sides here. So let's say we have parallelogram G, H, I, J for number 2. And let's say this side right here, side GH, is 17.4, and side IJ is x. So what's the value of x? First of all, what do we know about parallelograms? We know that opposite sides of parallelogram, so this is parallel to that. Opposite sides of parallelogram are what? Opposite sides of parallelograms are congruent and parallel, but we just care about the congruency part here since we're dealing with measures. So we're going to state that opposite sides of a parallelogram are congruent. So what can we write? What statement can we write using this property? We can specify that GH is equal to JI. Okay, and I will substitute GH is 17.4 and JI is X. So that's basically the value of X. X is 17.4 units because it is opposite the side that has a measure of 17.4. All right, so let's go ahead and take a look at question 3. The assumption still is that all these are parallelograms. So this is a parallelogram right here. Bam. Okay, so let's say we have this side right here of the parallelogram is x plus 11. And this side is negative 7 plus 3x. Okay, this is parallelogram DEFG. Now, what do we know about opposite sides of a parallelogram? We talked about that earlier. Opposite sides of a parallelogram are what? They are congruent, right? So what can we write? What information can we write? What statements can we write using this property? We know that DG and EF are opposite sides, so they must be congruent. So DG is going to be equal to EF, right? So if we substitute, DG is negative 7 plus 3x is equal to EF, which is x plus 11. So by applying the property of parallelograms from geometry to this setup we have right here, we have this resulting algebraic equation with variables on both sides. Okay, so now we're going to flex our algebra muscles to solve this. Let's have the x's on the left side so we don't deal with negative x's. So we'll subtract x from both sides of the equation. And then we need the 7 over there, so we add 7 to both sides of the equation. And our final answer is going to be, so the x's add up, that's gone to 0. 3x minus x is 2x. We have 2x is equal to 11 plus 7, that's 18. And then to finish that off, we need to get rid of the 2. Use the inverse of multiplication, right? Because this is 2 times x. To undo multiplication, we'll use this inverse, which is division. So we divide both sides by 2. And we have the value of x. X is equal to 9. That's the answer to question number 3. All right, let's take a look at number 4. So in question 4, we have another parallelogram right here. Parallelogram PQRS. Okay, let's just mark it just to show it's a parallelogram. So opposite sides are parallel and congruent. But just saying that they're parallel is sufficient to conclude that this is a parallelogram. Okay. All right, so we're still solving for x here. So what statement can we write first of all with this information that we have? We need to solve for x using these two adjacent angles. Adjacent angles of a parallelogram are what? Let's write it down. Adjacent, let me change my color here. Adjacent angles of a parallelogram are supplementary. Okay, basically they add up to what? 180 degrees. Okay, all right, so what can we write using that information? Measure of angle Q plus measure of angle P is equal to 180 degrees. That's the conclusion we can arrive at. All right, measure of angle Q is 7x minus 9 plus measure of angle P is 105. If you add these two, you get 180. So we're going to solve this resulting algebraic equation for x, and that'll be that. Okay. On the left side, we can combine like terms. We have two constants, negative 9 and 105, positive 105. If we combine those two, we're going to get 96, positive 96. So we have 7x plus 96 is equal to 180. All right, so let's get x by itself. We'll subtract 96 from both sides and divide by 7. Okay, so we'll subtract 96 from both sides of the equation. We're going to have 7x is equal to 10, 4. And then we have 17 minus 9, that's 84. All right, final step, we're going to get x isolated by dividing both sides of our equation by 7. And that will give us our x value. X is equal to 12. So that is the value of x, ladies and gentlemen. Okay, let's take a look at 5 and 6. These ones are a little bit more involved. So for 5 and 6, we're going to be finding the indicated measure, okay? So for number 5, let's say we have trapezoid U, V, W, T. Okay, so this side is parallel to this side. Remember, for parallelograms, opposite sides are parallel. They're also congruent too. So let's say angle V is 115x minus 1, and angle T is 114x. Okay, and for number 5, we have to find the measure of angle U. Alrighty, so if you want to find out what the measure of angle U is. So in order to do this, this is a 3-step process. So first of all, we have to find out what x is, okay? And then when we'll find out x, we can then use it to find v or t. Let's just find t. And then after we'll find t, we'll use it to find u because we know angle u and t are adjacent angles, okay? So let's outline our steps real quick before we start. So our steps are as follows. Number 1, we're going to find x. Okay, and then number 2, we're going to use that to find the measure of angle t. And then number 3, we're going to use the measure of angle t to find the measure of angle u. All right, let's do it. So let's start with part 1. Let's find x. So to find x, we know that, what do we know? These two are opposite angles, right? So opposite angles of a parallelogram are what? Opposite angles of a parallelogram are congruent. Okay, so that helps us to see that measure of angle V is equal to measure of angle T. So we substitute, we have 115x minus 1 is equal to 114x. To solve this, we're going to go ahead and subtract 114x from both sides and then add 1. Okay, let's do it. So we're going to subtract 114x from both sides of the equation. I need the x's on the left so I don't do any negative x's, and then add 1. Add 1. All right, so let's combine this together. Simplify that to get our final answer. 150 minus 114 is just x. Minus 1 plus 1 adds up to 0. This also add up to 0, and then that's just 1. Okay? So these ones go to 0. These add up to 0, and you just have 1. Okay? So x equals 1. Are we done? Nope, we're not done yet. We still have 2 more steps to go. Okay? All right, so let's move on to step number 2. So for step 2, we need to find the measure of angle T. We could have used angle V, doesn't matter, okay? So the measure of angle T is 114x, and we know that x is equal to 1. So how do we put these two pieces of information together to find the measure of angle T? What we'll do is we're going to take this value, x equals 1, and plug it into the measure of angle T, okay? So if we plug that in there, we're going to have the measure of angle T is 114 times 1, which is just 114. Almost there. Now, the last step, we need to find what we actually want to find, which is the measure of angle U. All right, so this is what we need. Angle U and T are adjacent, so what do we know about adjacent angles of a parallelogram. We know that adjacent angles of a parallelogram are what? Supplementary. Okay, so these two, if you add them together, you get 180. So how does that help us? Well, let's go ahead and write down the following equation. So we have the measure of angle U plus the measure of angle T. These two adjacent angles are supplementary, which means they add up to 180. Okay? From step 2, we know that measure of angle T. I didn't put it in. Sorry. Measure of angle T is 114, right? So the measure of angle T is 114, so we're going to sub that in here. So we have the measure of angle U plus the measure of angle T, which is 114, equals 180. Okay? So to get measure of angle U isolated, we're going to subtract 114 from both sides of the equation. All right, and that will wrap things up for us. So you subtract that, and then you get the measure of angle U. So you borrow 1 there. 10 minus 4 is 6, and then 17 minus 11 is 6 also. Measure of angle U is 66 degrees, ladies and gentlemen. So that's that for question number 5. All right, we're going to take a look at one more problem, problem number 6, and then we'll give you an opportunity to try out some practice problems on your own. See how well you've mastered the contents of this presentation, okay? So here I want to find CB, the following measurements. Let's say parallelogram A, B, C, D has a situation where AD is x plus 7 and BC is 2x minus 5. Alrighty? Okay, so let's just mark this to show that it's a parallelogram. So opposite sides are parallel. That's sufficient to indicate that this is a parallelogram. All right, so our work involves AD and C and BC, right? We want to find CB, but we notice CB has a variable in it, so that means that it's going to be a multi-step process. For number 6, let's write down the steps that we're going to take. First of all, we need to find x, okay? After we find x, we can now use that x to find measure of angles of side CB, because measure of side CB is dependent on x for its value. Okay? All right, let's do the first part. Let's find x. Now to find x, what do we know about these two sides? They're opposites, right? Opposite sides. Opposite sides of a parallelogram are what? Opposite sides of a parallelogram are congruent. Okay? Alright, so this property can help us set up an equation that will help us find x. So let's set up that equation. We have x plus 7. No, wait, let's write down a statement first before we substitute, okay? So the statement that we can write is that AD is equal to BC or CB. So AD is equal to CB, doesn't really matter, okay? All right, so this side and this side are congruent since they're opposite. AD is x plus 7, and that's equal to CB, which is 2x minus 5. Okay, so let's get x isolated here. So we're going to subtract x from both sides since this x is a bigger positive. And then we're going to add 5 to both sides of the equation, like that. And then we'll have our answer. 7 plus 5 is 12. Okay, that's gone. 2x minus x is just x, and that's gone also. So x is equal to 12. Are we done with this problem? The answer is no. We're not done yet. We still have to do part 2, which is to find the length of CB, okay? All right, so let's use that. We know that x is equal to 12. The next part 2, is to find CB. Okay, we know that CB is given by the expression 2x minus 5 is dependent on x, right? And we know that x is equal to 12. So all we do is just plug in this x value here and solve. So CB is equal to 2 times 12 minus 5. So we're going to use order of operations to finish this off. Please excuse my dear Aunt Sally. So using PEMDAS, what do we do first? Multiply or subtract? Using PEMDAS, we multiply first, right? Multiply and divide from left to right before you add or subtract from left to right. 2 times 12 is 24. 24 minus 5 is equal to 19. Ladies and gentlemen, that is the length of side CB. It is 19 units long. Alrighty, so now we have 6 practice problems that we would like you to try out. All these are all parallelograms. For question number 1, 2, 3, and 4, you're just solving for x in those ones. And then for 5 and 6, it's clearly indicated what you're looking for. For question 5, you're looking for the measure of angle the measure of angle x. And then for number 6, you're looking for the length of side TS. Alright, so go ahead and pause this video presentation at this time. Attempt these 6 problems. When we are done. When you are done, we're going to display the answers so you can check how well you did. Welcome back. So hopefully you had a chance to try these practice problems. Let's take a look at the answers. Question number 1, x is 63 degrees. Number 2, x is 18 units long. For number 3, x is 11. For number 4, x is 4. For number 5, the measure of angle x is 145 degrees. And then for side TS, TS is equal to 17 units. Ladies and gentlemen, how well did you do in these practice problems? Let us know in the comment section below how well you did. And if you have any questions on these practice problems or what we went over in this presentation, just specify it in the comment section and we'll be more than glad to assist you. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful in your studies of parallelograms, do give us a like or thumbs up. Your positive feedback is extremely important to us. Do not forget to subscribe to our channel. We upload videos to our page on a regular basis. And also to gain access to a wide variety of resources to help you do well in geometry, just visit our website at mathgotserved.com/geometry. Thanks again for watching and have a wonderful day. Goodbye.